After the 4 layers of invert concrete had been applied and the shoulders fitted in the west and east tubes of the Rastatt Tunnel, it was possible for work to begin on installing the slab track in the west tube. The Rastatt 2000 system is being used in the Rastatt Tunnel. The Rastatt 2000 system has already proven its worth in many infrastructure projects. In the Rastatt Tunnel, we use the great flexibility of this system to adapt it specifically for areas with and without mass spring systems. The centerpiece of the track system is formed by bi-block ties, each consisting of 2 single tie blocks and connected by means of reinforcing rods. These are industrially prefabricated. This guarantees optimal concrete quality and the highest level of precision. The long welded rails were delivered to the construction site by eco-friendly train. An assembly site was set up in the west tube trough in order to assemble the 120-meter track sections. To assemble a track section, around 180 bi-block ties are first positioned on an assembly siding at the correct intervals with the aid of an excavator. The 2 long welded rails are then lifted onto the rail fastening system using 2 excavators with manual aid and the tensioning clamps aligned. The excavators run on a parallel temporary logistics line. The tie bolts are mechanically tightened and the rails fixed to the ties in this manner. As soon as the track section is completely assembled, the installation train, consisting of 10 bogies and 10 hydraulic track lifters, is pulled onto the new section of track with the aid of a railroad excavator via a connecting ramp. At the other end of the rail section, the excavator and the bogies drive down onto the existing track, again via a connecting ramp. The 10 hydraulic track lifters, each manned by a worker, are now distributed evenly across the rail section. Gripper arms hook under the rails, hydraulic rams are extended and push the rail section with the track lifters on it upwards. The 10 bogies are then positioned under the track section, each one under a track lifter. The rams are then hydraulically retracted. The entire track section with the track lifters is now positioned on the bogies and pushed into the tunnel to the installation site by means of the railroad excavator. At the installation site in the tunnel, the entire system is pushed down onto a provisional line of the same length from the track already laid via a connecting ramp. The track lifter rams are extended again and push the entire track section upwards. The excavator is used to pull out the free bogies onto the track already laid. The connecting ramp is removed and the provisional track on the other side pulled forward as far as the elevated track section. The track lifters now slowly lower the track section onto the bed in front of the existing line. The 2 rails on the new track section are bolted to the rails of the track already laid. The joins are later welded. The grippers are now retracted again, and the 10 track lifters are assembled, coupled to the bogies and the excavator used to pull them back to the pre-assembly site in the trough. There, the next completed track section is already waiting, thus achieving high efficiency per day shift. Using this installation technique, we have laid up to 360 meters of track in the tunnel tubes and troughs. After the tracks have been laid, they are exactly aligned with millimeter precision and the base plate concreted. To this end, rails for a 750 millimeter narrow gauge track were laid on the narrow shoulder and used to transport the concrete through the tunnel to the installation site. An agitator with a capacity of 8 cubic meters is transported to the installation site in an electric locomotive. The tracks have to be aligned before being encased in concrete. For rough alignment, a track lifter gradually lifts the tracks to enable spindles to be fitted, which then keep the track elevated. The tracks are then adjusted with millimeter precision using the lever system in a mobile measuring device, the so-called Gado. Height-wise, this is achieved via the spindles and the position of the tracks adjusted with a special ratchet in a carriage construction. A bed of reinforced concrete is then cast around the realigned tracks. To do so, a swivel conveyor belt is fixed to the agitator with the aid of which the concrete can be precisely applied. The tracks with the tensioning clamps are covered during concreting to avoid contamination. The concrete is then manually smoothed to ensure a perfect smooth surface. After the concrete has hardened, the track is now firmly connected to the bed.
in dem Bereich.
In areas with residential development below the town of Rastatt, the slab track is fitted with a mass spring system. Thanks to the mass spring system, the slab track is decoupled from the tunnel floor, and vibrations from future rail traffic are mitigated.
Abgemindert.
So-called decoupling mats are mounted on the sides of the trough, and elastic rubber mats laid on the bed. The reinforcement of the mass spring system is now installed on these elastic rubber mats. The mass plate is subsequently concreted in 2 sections. The ties and rails are then mounted on the lower mass plate and their position adjusted in situ by means of rough and precision alignment. Subsequently, these tracks are also concreted. Finally, concrete slabs are laid on the bi-block ties. These concrete slabs can take the weight of trucks and automobiles up to an axle load of 10 tons. This is an important element in the safety concept of the Rastatt Tunnel. Over 12,000 slabs were installed in both tunnel tubes together with the troughs. Around 100,000 cubic meters of concrete and 2,000 tons of reinforcement were used for the entire fit-out. This has resulted in around 12,000 meters of slab track in both tunnel tubes and groundwater troughs. After the tracks have been completed, work will start at the end of 2024 on connections to the existing line, as well as the technical equipment.